Well, I couldn't wait to get back to work after I finished up the installation of the dust collection system here in the down-to-earth woodworking shop. Fact is, I had a few projects I was getting a little behind on, so I needed to get back to work. But I also wanted to season the system in, get some chips and dust flowing through it before I started taking measurements so that I'd get good, accurate readings. And the fact of the matter is, I'm still tweaking a few things here and there on the dust collection system. Well, here's an example of one of the tweaks that I made after the installation was complete. This is my little planer. Dust ports out through this elbow, and I cut a section of hose here to connect from the port up to the blast gate on my ceiling drop. When I ran the machine and ran some boards through, I got no static electricity at all building up in the pipe itself, but this hose got charged pretty good. So what I did was I used a piece of scrap leftover copper wire from the rest of the static installation. I put a couple of spring clips on either end, and I made a little jumper wire. So up here at the top, it's clipped to the blast gate. I loosely wound it around the hose and came down and clamped it to the hose clamp down here at the bottom. And now there's no static buildup in this hose. Well, I want to give you a tour of the whole dust collection system, and probably the logical place to start is upstairs with the dust collection machine itself. So let's go upstairs. Well, you've already seen in a prior video how easy the JDS dust collection system was to assemble. What you might not have seen is some of the features of this unit. First of all, while the size is quite compact, both height and footprint, it's a very powerful machine. This 2 horsepower motor up here turns at 3,450 RPM, and the rating on the machine is 1,700 CFM. And I don't doubt at all that it would generate that kind of cubic feet per minute of air movement at this big honkin' 8-inch intake port. This is the main manifold coming out of the JDS dust collector, and they supply with the machine an 8-inch to 2 4-inch outlets, which can be put on the machine, and you can run 2 4-inch lines off of it at the same time. I wanted to keep my run as large as I could practically afford to do, so I reduced from 8 to 6 and ran 6-inch pipes for my main manifold, and then transitioned to 4-inch lines for all of my branch and drop lines. Why didn't I go with 8-inch? Well, pretty simple. A 6-inch elbow, Y, or pipe costs about 2 to 2.5 times as much as a 4-inch. But when you jump to 8-inch, the cost goes up as high as 4 times as much. In addition to the big motor that turns the impeller is this little gear motor over here. This is on a circuit in the control panel so that when you turn the dust collector off, a few seconds later a signal is sent and this gear motor turns flappers inside the filter, which knock the dust off. Now, most dust collectors these days include some way to manually flap those filter pleats and remove the dust. This is the only machine I know of that does it automatically for you. As you can see, after a couple of bucket loads of dust and chips, I've managed to collect a little bit of dust in this plastic bag from the filter itself. One of the other things that I liked about the JDS was the relative ease of emptying the dust collection bucket. Simply lift these 2 levers, the lid comes up, roll the bucket out. Right now I have a plastic liner in here. I don't really know if I'm going to continue to use that. I think that's probably great for some people. For me, it's easy just to grab the bucket and carry it outside and put it in my compost pile. But either way, it's so easy to use. Just roll it back into place, clamp the lid back down, and you're ready to go. As long as we're upstairs with the machine, I thought we might start taking some readings. The first thing I'm going to do is measure the dB or sound output of the machine. Now I'm measuring this at 6 feet. I don't know what's standard in the industry, but any machine I test, I always test it at 6 feet just so my readings are consistent from machine to machine to machine for comparison purposes. So let's turn this thing on and let's see what we're reading. Okay, that was registering a pretty consistent average 89 dB. Now the manufacturer rated this at 74 dB, but some of this could have to do with the acoustics in this sort of vaulted, slanted ceiling area. Some of it could have to do with where they took their measurements. If they took their measurements at 10 feet or 12 feet as opposed to my 6 feet, the difference would be pretty pronounced. So that's not too bad. What I'm really interested in is what the reading's going to be downstairs. Now in just a second, you're going to hear the flapper motor run that is cleaning off the inside of the filter pleats. Let's listen for that. And for what it's worth, that averaged about 80 dB, that little sound. First time I heard that, it scared me a little bit, but I think it's a pretty cool feature. Another important measurement to take is vibration, and I'm going to take that reading right now. Okay, so I've got this program to take a 5-second average reading. And the reading on the machine itself was an RMS magnitude of 0.113. Now I want to measure the floor around the machine to see how much vibration is being transmitted through the structure. So let's do that now. Okay, the RMS magnitude vibration measured on the floor next to the machine was 0.114. It's actually quite a low reading. Well, that was a pretty impressive vibration reading, and now I'm going to blow your mind. You've probably seen this done before, maybe with a table saw. I can do it all day long every day with my Rikon bandsaw, but I bet you've never seen anybody balance a nickel on top of their dust collector. Let's take a look. That's pretty impressive, folks. And that's a real nickel. Okay, now I've got the dB meter, which by the way is a program that you can get for your iPhone. I have another dB meter and I've checked it against that meter, and this thing is dead on accurate. It's made by dB Meter Pro, I think is the name of the company. You can find it on the iTunes store, but it's a great little app if you want to check some of your own machinery. But I've got this set up basically dead center in the shop downstairs, and now let's measure what the dB rating is of the dust collector down here. So it looked like there we were reading pretty consistently 83, 84 dB. So I think that's pretty much the sound level. I'm not sure how the manufacturer got 74 dB in their specs, but I think 83, 84 is about what I'm going to expect, and I'm still pretty good with that. It's still way less than my planer. So before we start to take performance measurements of the dust collection system, let's take a look at the ductwork. I'm over here by the miter saw station, and this drop is the one that's the furthest from the dust collector. If I ever figure out some kind of hood to actually capture some of the dust that flies off that wild machine, it'll be very convenient having a ductwork drop right here. When I put in this last drop by the miter saw station, I did stub out some extra pipe and put a cap on the end of it, just in case I had the opportunity to do any future expansion. From the miter saw drop here, this goes through a Y fitting and into this pipe that crosses across the wall. This is the next drop coming down the wall from the miter saw station. This drop is primarily for my router table. So as you can see, same setup. I've got my static wires coming down, junctured in and tied up. I've got a Y fitting here that moves into this pipe, and now we're going to go around the corner. In this corner, to make the 90-degree turn, I used two 45-degree L's and a piece of pipe between to make a smoother turn. From the corner, this pipe then goes down to the main manifold. But before I show you the main manifold, let's take a look at a couple of the drops in the middle of the shop. But anyway, this is the drop that's out in the middle of the shop, and it's hard to see from that angle, but like over by the miter saw, I extended this pipe out and put a cap on it past this Y. The reason that I did that is for the potential of future expansion. One can always hope. From the middle of the shop, this line now comes across and drops another drop right here with another blast gate. And this is for any machine that I may want to pull up in this area and park and extract dust from. From there, we go to the main manifold. And let's take a look at that now. Okay, so this is now where everything sort of ties into the main manifold. This is the line, goes over to the miter saw station and to my router table drop, and it comes down and connects into the main manifold. Branching off that is a line that goes out across the ceiling of my shop, providing the drops that I showed you a minute ago. You can see all the static wiring all tied together here with all these connections, and coming over here to the main manifold line. Now this is 6-inch pipe. Here it reduces to 4. We go 6-inch up through the ceiling, and you've already seen where that was tied into the machine. And we go 6 inches down here till we get down to about waist high, and then we make a transition. Let me show you that. Okay, so here is our 6-inch pipe coming down, and now we have a Y, which is a transition Y, down to 4 inches on this side. It's still 6 inches here, but then I have a reducer here inside that reduces it down to 4 inches, which goes down to the floor sweep. Now, you may have seen these little pieces of tape scattered around. This was an experiment that I tried that just didn't work out. I thought because of some of these loose wires, the way they were on the fittings, it would be a good idea to kind of attach those wires to the fitting itself. And I found something that's called conductive glue. And the glue does conduct electricity. Unfortunately, the glue doesn't stick to PVC. It just flakes right off. So that was an experiment that didn't work, and I think I have another idea for that. And maybe one of these days, if it ever comes in, the product that I'm looking at, maybe we'll experiment with that a little bit. This is, again, the transition down to 4-inch, got a blast gate here, and we go down to a floor sweep. And the floor sweep is a pretty cool feature, and it works pretty nice. It is actually almost scary how strong this thing is. But this is going to be handy for picking up those shavings when I'm hand planing. Okay, for testing the CFM, I've got a piece of what is arguably the least good piece of hose that I have. Was that politically correct? Least good? This, as you can see, you're looking for a smooth wall on the interior. You may not be able to see this, but the wire ridges are extremely pronounced on the inside. This particular hose is also real prone to static electric buildup, whereas the clear hose that you'll see in a minute seems to build up a lot less static electricity. But still, I'm going to use this because it's rough and ragged on the inside, and I don't want to do anything that will overly advantage the dust collection system. So all I'm going to do is I'm just going to put this on here, open up the blast gate, and we're going to take some readings at the end of this hose. Before we do that, let me show you the test meter we're going to use. Alright, so what we've got here is a digital anemometer. I had to practice to be able to say that. Anemometer. This will take a number of different kind of readings: wind speed, wind temperature, air temperature. But what we're interested in is CFM, or cubic feet per minute. To measure CFM with this machine, you put it into CFM mode, and then you enter in the cross-sectional area dimension of the pipe the air is moving through. And of course, to do that, you simply get the radius, half the diameter, and then it's pi r squared to come up with the cross-section dimension. Once we do that, we're going to put this into average mode in case my hand is to move a little bit. And I'm going to hold this as steady as I can, about 3/4 of an inch to an inch away from the opening of this pipe. And we'll see what we've got. Now, what are we looking for? Well, there's charts all over the internet that you can pull up. And I've seen recommendations of 400 to 450 CFM for a table saw, up to 500, 550 CFM for a jointer or a planer. We're just looking, bottom line, for the biggest number we can get. So let's take a reading. Well, I got to tell you, I'm pretty happy with that. Averaged about 560 to 570 CFM here at the end of this not great hose over by the miter saw, which is the farther spot from the dust collector. So that's a good reading, and I'm very happy with that. Now let's go take a reading a little closer to the dust collector and see what we get there. Interestingly, it looks like we're reading about 530 to 540 CFM over here. Some of that may have to do with the length of this pipe or the kinks that I've got in it, but still a perfectly fine reading for any of my machinery. Now let's test the one drop that's out in the middle of the shop. Interestingly, as you can see over here out in the middle of my shop, from the ceiling drop, I'm reading over 600 CFM real consistently. That's interesting. Either way, I'm very happy. Anything above 400, 450, I was going to be thrilled with. So I'm pretty happy with the CFM movement on my new dust collection machine. Well, for the last half hour or so, I've been planing some ash boards pretty, And in all that time, well, I wouldn't do this for just anybody, but not any electrical shock at all. In fact, in all the time I've run this, I've built up no static electricity on the PVC pipe, and since installing this little jumper on this hose, I haven't built up any static here either. So I'm pretty pleased with the static dissipation system. By the way, just so you know, there was no fudging on the static test. My shop is currently 63 degrees inside with a relative humidity of 26%. Pretty much perfect conditions for building up a nice static electric charge. Well, I guess you could get all high-tech with checking for leaks in your system. I frankly wasn't that worried about little minor leaks in my ductwork system simply because the machine's got enough power to overpower any leaks. Here's something that you can do that's pretty easy if you want to check for leaks on your system. These are called smudges, and think of it as like incense on steroids. This one happens to be sage, so it'll make your shop smell really nice. And what you do is, just like incense, you light this, let it burn for a second, and then blow it out, and you get a lot of smoke off of it. And you can use this smoke to check for leaks. There's not really any smoke like heading right for that blast gate. You want to see how it can, if it was leaking a little bit. You can see it would pull that smoke directly in. So that's pretty good. Now all you got to do is just take this around and follow your ductwork, and you can tell where you've got leaks. And if nothing else, it'll make your shop smell really nice. I hope you enjoyed this wrap-up video of the installation of the dust collection system in the down-to-earth woodworking shop as much as I enjoyed sharing it with you. If you're interested in reading a more detailed review of the JDS Cyclone, I'll be putting that into Highland Woodworking's Wood News online newsletter in a few weeks. Be sure to look out for that. In the meantime, thanks again for watching, and I'll look forward to seeing you in the next video, which, by the way, is going to be a tour of the shop. So I gotta go start cleaning up.